In this video, I'll be explaining how to solve for the unknown A, B, and C. Here, I'll be using three methods, and the last method is the most important one. Please stay tuned till the end before you comment. Now, here we have A plus B equals to 4. I'm going to make this to be my equation 1. And we have B plus C equals to 6. This is going to be my equation 2. And A plus C equals to 8 is going to be my equation 3. Now, rewriting equation 1, we have equation 1 to be A plus B equals to 4. By rewriting this given equation, we're going to have A to be equals to 4 minus B. And I'm going to name this equation 4. Now, I want you to substitute our new equation 4 into equation 2. So here we have our A to be 4 minus B. So let's put this in equation 3 because equation 3 has A. So instead of having A, I'm going to change it with 4 minus B plus C equals to 8. So rewriting this given equation, I can say my C is equals to 4 plus B. And this is going to be my equation 5. Interestingly, I'm having two new equations, equation 4 and equation 5. So what I'm going to do next is to substitute my equation 5 into equation 2. Why? Because equation 2 has B and C. So my equation 5 is going to be, new equation is going to be, let me rewrite this equation 2. Equation 2 says B plus C is equal to 6. So here, I'm going to have my B, and my new C is going to be 4 plus B, which is going to be equals to 6. So here I have 4 plus 2B is equals to 6. And my 2B is going to be equals to 2. By simplification, B is going to be equals to 1. Now, I've gotten the first value. And my first value is B equals to 1. By proceeding from equation 1, recall that my equation 1, so here we have from equation 4, let's use equation 4. We have our equation 4 to be equals to A equals to 4 minus B. So since B is equals to 1, then we can say that A is equals to 4 minus 1. And A is going to be equals to 3. So we've gotten the second value. And for the last value, let's use from equation 5. Going up here, equation 5 is this. C equals to 4 plus B. So we have C to be equals to 4 plus B. And here my C is going to be 4 plus, the value of the B is 1. 4 plus 1. So C is going to be equals to 5. So therefore, we have A to be equals to 3, B to be equals to 1, and we have our C to be equals to 5. You can check by plugging in this into the given equation. We have A to be equals to 3, we have B to be equals to 1, and C to be equals to 5. If you plug in 3 plus 1 gives 4. If you plug in 1 plus 5 gives 6. 3 plus 5 gives 8. So that shows what we've gotten is absolutely correct. This is method 1. Let's proceed to use method 2. Recall, I told you we're going to be using 3 methods, and the third one is the most important one. For method 2, Here we have, from the question, let me write the question for follow-up. We have a plus b is equals to 4, b plus c is equals to 6, and a plus c is equals to 8. Now, adding up all the given equations. So here we're going to have a plus b plus c plus a plus c, all is equals to 4 plus 6 plus 8. So here I'm going to have a and a, which gives 2a. b and b, we have this to be 2b. c and c gives 2c. And this is going to be equals to 18. Dividing through by 2, divide all by 2. To break it down, here we're going to have a plus b plus c is equals to 9. Let's make this to be our equation 4. Okay, now let's do something interesting here. You can say equation 4 minus equation 1. Okay, so equation 4 is a plus b plus c minus our equation 1, which is a plus b. This is going to be 9 minus 4. So a cancel out a, b cancel out b. So here I'm going to have my c to be equals to 5. Also, from equation 2, we have b plus c equals to 6. So from here, we can see that our b is going to be 6 minus 5. And b is going to be 1. Also, from our equation 1, we have a plus b is equals to 4. So we have a plus 1 is equals to 4. And here we have a is equals to 4 minus 1, a is equals to 3. Therefore, we have our a to be equals to 3. We have our b to be equals to 1. Here we have our b to be equals to 1. And we have c to be equals to 5. We will be using the Gaussian elimination method to solve this given problem. To use this Gaussian elimination method, or we can also call it the matrix method, let's rewrite this given equation. This is my equation 1, equation 2, and equation 3. Now, by writing this here, I'm going to focus on the coefficient. Here I have a plus b plus 0c, because 0 times c is the same thing as 0, equals to 4. And here I'm having 0 times a plus b plus c is equals to 6. Here I have a plus 0b plus c equals to 8. Now, transforming this into matrix form. This can be transformed by writing out the coefficients. Here I'm going to have 1, 1, 0. So here I'm having 0, 1, 1. And here I'm having 1, 0, 1. So this is equals to 4, this is equals to 6, and this is equals to 8. Now, our objective is very simple. What we intend to do is to have upper triangular matrix. So our objective is to make this to be 0, so that we can have the whole of this to be different. And this to be 0. That is our objective. So what we're going to do now is to reduce the matrix. So I'm going to move this matrix down here and start the reduction. Now, here I'm going to have the matrix being reduced. Here I'm having 1, 1, 0, 0, 1, 1, 1, 0, 1, 4, 6, 8. Now, looking at this line, this is my row 1. This is my row 2. And this is row 3. Now, next is to do row 3 minus row 1. What is our objective? Our objective is to get rid of this 1 and have a triangular matrix. So now we have row 3 minus row 1. Nothing happens to the first row. So we're only working with the last row. So here we have 0, 1, 1. So 1 minus 1 gives 0. 0 minus 1 gives negative 1. And 1 minus 0 gives 1. So we have 4, 6. And the last one here, 8 minus 4 gives 4. Now looking at this, we still have problem with this. Our major concern right here is we want this also to be 0. And to do that, the next thing I'm going to do right now is to do row 3 plus row 2. Row 3 plus row 2. And by doing that, here I have my row 3, which is 0 minus 1. Row 3 plus row 2, which is 0 plus 0. Let's repeat the previous one. We have 1, 1, 0, 0, 1, 1. Now, here we have 0 plus 0 to be 0. Negative 1 plus this 1 gives 0. And 1 plus 1 gives 2. Here we have our 4. We have our 6. So 4 plus 6 here gives 10. Finally, our objective has been matched. And what is our objective? We want the whole of this to be 0. So we can have the upper triangular matrix. Now, looking at this, if you look at this carefully, here we have our coefficient to be A, B, C. A, B, C. A, B, and C. So what are we going to do? So looking at this, what we're going to do is very easy. We want to compare the coefficient. Here, from the last part here, we have our 2C to be equals to 10. And from here, our C is equals to 5. Moving to the second row, we have our B plus C to be equals to 6. So here we have our B, which is, our C to be 5 equals to 6. And here we have our B to be equals to 1. And looking at the first row, we have A plus B to be equals to 4. We have A plus 1 to be equals to 4. And here we have A to be equals to 3. If you plug in this to the given equation, you will confirm that this is absolutely true. Thank you very much for watching my videos. Please subscribe or put your suggestion in the comment section for further review. Bye. See you later.